We're going to look at these various polynomial functions and see what we can determine. The first question is, how many x-intercepts does it have? How many times does it cross the x-axis? 1, 2, 3. And that is cross or touch. So it has 3 x-intercepts. How many turning points? 1, 2 turning points. Now, is the leading coefficient positive or negative? What does it do to the right as it goes to positive infinity? As x goes to positive infinity, y goes up, so the leading coefficient is positive. What is the degree of this polynomial function, odd or even? Remember, even functions, both up or both down. Odd functions, one up, one down. So this being one end up, one end down, and one up, this must be an odd. Now, the question is the minimum possible degree. Well, remember, a function of n degree has at the most n intercepts, and turning points is n minus 1. So this looks like it's a third degree function. How many x-intercepts? 1, 2, 3, 4 places it crosses the x-axis. How many turning points? 1, 2, 3 turning points. Is the leading coefficient positive or negative? Well, as it goes to the right, it goes up, so the leading coefficient is positive. Is this, the degree of this polynomial function, odd or even? Since both n behaviors go the same direction, it is even. And the minimum degree, well, it has x-intercepts, so that's our minimum degree. X-intercepts, x minus 1 turning points, our minimum degree is 4. Then we have the complete graph, the number of x-intercepts. Now, this only has 1, 2 x-intercepts. It only crosses, it touches in one point. So it has 2 x-intercepts. And how many turning points does it have? 1, 2 turning points. Is the leading coefficient positive or negative? As we go to the right, as x goes to positive infinity, y is going to negative infinity, so that leading coefficient is negative. Is the degree of the polynomial function odd or even? Well, since the n behaviors are different directions, it will be odd. The minimum possible degree of this function? Well, it has 2 turning points, so, and to be odd, it must be 3. And the number of x-intercepts is 2, but because it's a turning point right on the axis, the minimum degree is 3. Here's a unique function for us. We want the number of unique appearing, we want the number of x-intercepts. Well, I see 1, touches 1, 2, 3, 4 x-intercepts. How many turning points does it have? 1, 2, 3, 4. 4 turning points. Is the leading coefficient positive or negative? What is the behavior as x goes to infinity? Y is going to positive infinity, so the leading coefficient is positive. And the degree, is it even or odd? My n behaviors are opposite, so it's odd. And what's the minimum possible degree? Well, if it has 4 turning points, it must have, that's n minus 1, so 5 must be the minimum possible degree of this function. Using data from 1982 to 2005, the total number of fatalities in drunk driving crashes in South Carolina can be modeled by this function. Y equals negative 0.0395 x to the fourth plus 2.101 x cubed minus 35.079 x squared plus 194.109 x plus 100.148, where x is the number of years after 1980. We want to graph this function on a window with values of x representing the years from 1980 to 2005 as being our maximum number of accidents. This is an interesting looking graph. Next, they ask us how many fatalities occurred in 2005 according to this model. If we go back to our graph, we want how many fatalities in 2005. That's when x equaled 25. So we can go to second calc. We want the value when x equals 25. And we'll find out that it's 426.9. Unfortunately, we can't have only part of a person with. So how many fatalities occurred in 2005? We had 427 fatalities. Using this model and technology, estimate the year in which the number of fatalities from drunk driving was at a maximum. Looking at our graph again, the maximum appears to be over here. So we'll do the second calc. We want a maximum, and that's 25, so we have to be somewhere over here. Let's say 15. The right side we could say to 25. And let's take a guess at 23. Well, at 22.7, so that appears to be 2003. We had 517.9, so 518. So it appears that in 2003, there were 518 accidents from drunk driving, fatalities from drunk driving. The next slide, we want to know the estimate. We want to estimate the year between 1981 and 2005, which the number of fatalities, crashes was at a minimum. Going back to our graph, minimum appears to be here. So we want second calc. We're looking for a minimum. Yeah, this appears to be in the middle, around 12 or 13. So let's say something over here might be 5 for the left side, might be 20 for the right side, and we can take a guess at 15. We found out it's 12.99, so that appears to be 13, and 182.9, so 183 fatalities. So in 13, added on to our 180, will be in 1993, we had 183 fatalities.